Hello, in this video, we will introduce Breadthfirst Search. The Breadthfirst Search or Breadthfirst traversal of a graph is like the Breadthfirst traversal of a tree. With Breadthfirst traversal of a tree, the nodes are visited level by level. First, the root is visited, then all the children of the root, then the grandchildren of the root, from left to right, and so on. Similarly, the Breadthfirst search of a graph first visits a vertex, then all its adjacent vertices, then all the vertices adjacent to those vertices, and so on. To ensure that each vertex is visited only once, skip a vertex if it has already been visited. Let's look at this graph here. Suppose we're going to start from 0. First visit 0, then we visit all the neighbors of 0, 1, 2, 3. And then all the neighbors, that's 4. So that is the Breadthfirst search of this graph. We give the algorithm as follows. Breadthfirst search, starting from vertex V, returns a tree. The tree has this root and all the parents, and also the order of visiting all the vertices. So let's create an empty queue for storing vertices to be visited. Add V into the queue. Mark V visited. While the queue is not empty, we're going to dequeue a vertex, say U, from the queue. Visit U for each neighbor W of U if W has not been visited. So we're going to add W into the queue, mark W visited, and set the parent of W to be V. So using a key, we ensure that all the neighbors are visited before neighbors. So let's look at the implementation of the Breadthfirst search in listing 26.3. This is the implementation of the Breadthfirst search. So this is the Breadthfirst search right here. So we have the search order is a vector. This the parent is a vector. And initialize all this with value -1. So here's the queue. Use the queue to store the vertices to be visited. So this is the vector is visited. So this is visited right here. And this is the, we're going to push this V into the queue. Is visited of this vertex V is now true. So while the queue is not empty, so we're going to queue front, get 1 from the queue. So that is U. And so using this queue pop, remove the front element and put this U to the queue. So get all the neighbors of this U now. Look at all the edges. So we get this is the E. So let's pick this W here, and the E has this 2 ends, U and V. So look at the V ends. If W has not been visited, I'm going to push W to the queue and set the parent of W to U, and this is visited now becomes true. So after all this, done, this while loop is finished. So we have this tree now with starting from the root is V, and here the parent and the search order. That is all for the implementation of the Breadthfirst search in a graph. So let's look at the test program. We have this vertices, all the cities and edges. So this is the US map with all the cities and the edges as the connecting vertices. And this number of edges, 46. So we create a graph. So using the vertex, this is the vertex. And using a vector of vertices and edges, number of edges. So get the Breadthfirst search tree starting from 5. 5 is Chicago. And now we get the Breadthfirst search, get the search order. So this should be a Breadthfirst search. So I'm going to change it to Breadthfirst search. And so we're going to change everywhere. There should be a Breadthfirst search and get the number of vertices font. And then we get the, and all the parents. So this is the parent of Seattle is Chicago. The parent of San Francisco is Seattle. And parent of Los Angeles is Denver. So this is the test of BFS. So this is Breadthfirst search. Applications for the BFS. So you can use BFS to solve the problems as follows. So all these problems listed here, most of this can also be solved by the application of the depth-first search. So let's look at this, the problems. Detecting whether a graph is connected. Detecting whether there's a path between two vertices. Finding a shortest path between two vertices. So this is, you have to use the Breadthfirst search. And I think all the other problems, well, this one here, testing whether a graph is bipartite, and you have to use the Breadthfirst search. So this, detecting whether the graph is connected using either depth-first search or Breadthfirst search, detecting whether there is a path between two vertices. So both, and finding a shortest path, that's, you have to use the DFS. Finding all connected components using both, and any of this depth-first search or Breadthfirst search. Detecting whether there's a cycle in the graph, you can use Breadthfirst search. Finding a cycle in the graph using Breadthfirst search, that's fine, or depth-first search. Testing whether a graph is bipartite, so you need to use the Breadthfirst search. Bipartite is this graph. A graph is bipartite if its vertices can be divided into two disjoint sets such that no edges exist between the vertices in the same set. So it divided into two sets. Only the edges are between the vertices in the two sets. That is all for this section on the Breadthfirst search. See you on the next video.